morning again. I'm still in section 2.2, and we're going to look at 3 different stem and leaf plots. Stem and leaf plots' purpose is basically to get a quick look at the shape of the distribution. So we're going to look at just a plain old regular one, look at how a split one looks like and what a back-to-back looks like one. So this regular one, I'm actually going to set up 3 of them. So you can fast forward if you need to. But the idea is that you create a stem and then the leaves are only 1 digit. So the stem can be anything you want, but then the leaves are only 1 digit with no commas or spaces or anything like that. So our first example is a book problem actually that I stole. It's the hours per week, the hours worked per week from a sample of 24 nurses. And so we see 40 hours happen quite a bit. The max looks like what, 48? No, I'm sorry, the max looks like it's 50. What's your min? So we scroll through, looks like our min's at 24. So one way to set up a stem and leaf for this problem is to just say we're going to do a line with all the 20s, a line with all the 30s, a line with all the 40s, and a line with all the 50s. And we call those our stems. On the other side, there are leaves. So this first example is going to be a non-ordered stem and leaf. And so I'm just going to go through and read the top row. It's a 40, a 40, a 35, a 48, a 38, a 40, a 36, a 50, a 32, a 36, a 40, a 35, a 30, a 24, a 40, a 36, a 40, a 36, a 40, a 39, a 33, a 40, a 32, I ran out of room, and a 38. That's horrible. Okay, now that's not pretty. Why? Because we are talking about things that are in order, and so mathematically speaking, we'd rather see all these lines be in order. The other thing that might be nice is a split stem and leaf, so I'm going to show you that. Hang on one second. Okay, I had to make more room in my document. Okay, so if I was going to put this in order, then on the 20s line, we'd still just have a 4. But on the 30th line, you would have a 0, and then a couple of 2s, a 3, what, 2 5s, it looks like 4 6s, and 2 8s, and a 9. I hope I didn't leave anything out. I need more sleep, I think. The 50s line is good. The 40s line is good, just the 8 needs to be last. So there's 2, 4, 6, 8 zeros. And you can see that the mode clearly is in the 30s, right? 30s and 40s for sure. So you get an idea of what the shape of the data looks like, and maybe even kind of trace over it to see, oh, it's even fairly symmetrical. Okay, well, when we're talking about any graphs, they should always have titles and keys when necessary. So this was the hours worked by nurses. It's probably nice to say N is 24, meaning that's our sample size. And then we put a key for the reader. And it doesn't even have to be a data value that's in there. So for example, 2/5 would represent 25 hours worked in a week. Okay? All right. Now, I think because there's so many data points just in one line, that maybe a split stem and leaf would work better here. So you would have a 2, and then I put a dot, but some people put a secondary 2, and then a 3 and a dot, and a 4 and a dot, and a 5. I'm running into my next problem. Miss May, what a mess. Okay, so on the first line, you would just put anything that's from 0 to 4. On the second line, it would be 5 to 9. So I don't have anything on the second line for the 20s. For the 30s, though, on the first line, 0 to 4, and on the second line, 5 to 9. So for the 40s, the first line would have all those zeros. Would we say we had 8 of them? 1, 2, 3, 4, 5, 6, 7, 8. I asked you like you're going to answer me. Okay. And then maybe we might see a little bit of a change in the shape. In this case, I don't think so. I still would say that this is fairly symmetrical. And your key would still be the same, that 2/5 is 25 hours. Okay, so let me scroll back up for just a second. So the purpose of a stem and leaf is to look at the shape very quickly. We had a non-ordered stem and leaf right here just to see what's going on. That's a fast way to order things too. This is the exact same stem and leaf. I've just put it in order. This is still the same data, but now I've split the rows. So the first row should be 0 through 4, and the second row 5 to 9. Okay. Now I wanted to show you 2 more ways to look at stem and leaves because you don't always get data that's just 2 digits. So like back in example 1, all the data was 2 digits. So 1 digit was your stem, the other digit was your leaf. And so for example, I took some local GPAs. Can't see what I wrote there, but these are GPAs from a local high school. And the lowest one is a 1.2. We all know that's just awful. But look at this high one. This is just ridiculous. I mean, in the real world, the highest GPA is a 4, but here we have a 5.7. So I think for this problem, it might be obvious that I need a row for 1s, I need a row for 2s, 3s, 4s, and 5s, okay? And then the leaves will be the tenths place. Well, we do have one problem that's not 2 digits, it's 3. And so we'll round it to 4.8 for the sake of the chart. The graph is, remember, just to give us shape. So we don't want to make a big deal about rounding and things like that. So, okay. So I have 1.2, I have 3.1, I have 4.0, 5.7. I'm going to try to put it in order as I do it so I don't have to redo it. So for the 2s, I have a 1 and a 4, and then the 4.8 and the 4.4, so I have a 4 and an 8, and let's see, my 3s, and that's also going to count as a 4.8, right? And my 5.7. So there were supposed to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3, 6, 9, 10. Okay, I'm too tired. Who did I miss? So I grab my highlighter and let's mark them off. Here's my 1.2, I have the 3.1, I have the 4.0, I have the 5.7. I have the 2.4 and the 2.1, I have the 4.8. Oh, I missed this one. The 4.4, the 3.8, the 4.8, and I also missed this one. Okay, good job, Miss May. Well, the positive to that is you'd see me do these goofy stuff in class too, so there we go. Now your key, we'll say something a little bit different, so we'll do a 4.2 for example. So 4/2 would be a 4.2 GPA. Ta-da! We wouldn't want to split this one, it's not enough data. Okay, awesome. Well, I'm not going to work this last one. I said I wanted a split stem and leaf, but I don't think we even I don't know that we have that much data to do that. But I want to talk about what your stems would be. So if I scroll through all this data, and I can make it a little bit bigger for us, the lowest value in this column is 162. I don't have anything lower in this column, and I don't have anything lower in this column. So 162 is the lowest. And then if I'd wake up a little bit, I'd see that these are all actually in numerical order already for me. So there's my min and there's my max. So if my min is 162 and my max was 472, how do you set up your stems? Because remember, your leaves can only be single digits. So you would have to go from 16 all the way down to 47. Unless you were willing to round, okay? But in this case, probably not. And then your leaves would look like this, okay? And then your key would say 162 is 162 problems per 100 vehicles. Ta-da! All right, the last one's already created for us. I just wanted to show you this last one is called a back-to-back stem and leaf. obviously, because they're back to back. So we use it when we want to compare two things. So in this problem, we're comparing McDonald's and Burger King. If you take a second to read the problem, it's actually computing the number of grams of fat in 20 sandwiches served at each. And they share the stem column. So the stem column is actually in the middle right here. And then the leaves branch out. So for example, on the second line, you can see that Burger King starts at 2 and works its way out to 7. McDonald's starts at 0 and works its way to the left all the way out to 9. You can compare shapes. It's very easy to compare mins and maxes, modes, things like that. But we use it when we want to compare two data sets. So ta-da, there's my little bit about stem and leaves. Have a great day.